Alrighty, let's go ahead and get started with our page 5 of our experimental design notes. So you're going to see these three main categories. We're going to start with the scientific theory. Let me go ahead and pull up. Okay, so a scientific theory is a broad explanation for a natural phenomenon. And that's our definition. Broad explanation for a natural phenomenon. Some examples of scientific theories would include things like the theory of evolution. Theories often have been tested many times, and they are inferred explanations that are strongly supported by evidence. Theories can be used to make predictions, and often they explain why something is happening. That part is really important. Let's go ahead and highlight that. Okay. Now, a law is different than a theory. A law is what is happening. So, this describes a natural phenomenon. An example of this might be Charles' law or Newton's laws. Okay, getting into our hypotheses. So, a hypothesis is a proposed explanation for a narrow set of natural phenomenon. You can see the difference here. Hypothesis is a narrow set. A theory is a broad explanation. So we'll go ahead and highlight our definition. So hypotheses are based on prior knowledge. Oops, I spelled that wrong. Based on prior knowledge, background knowledge, and preliminary testing. It's often a statement that can be tested. So in order to be a hypothesis, you have to be able to test it. And then once hypotheses are tested over and over and over, they can become theories. Okay, so hypotheses are also predictions about the outcome of an investigation. So we might predict what's going to happen in an investigation. That's a hypothesis. It guides an investigation. What is being tested in that investigation? So often hypotheses are formatted in if-then statements. Okay, let's dive into this final section. Let me move you a little bit. Okay, so evidence. Evidence would be things like data. It's what happened in an experiment. So evidence is data. Now, an explanation is why something happened in the data, which makes sense. A good scientific explanation uses evidence to justify a claim. Without the evidence, your claim is kind of invalid. So this describes what you think the experiment showed. Both evidence and explanations support the claim and are used to respond to the testable idea, which would also be known as your hypothesis. We can never really prove something in science, but more testing and new technology could always disprove what we already know. So the thing about science is that we're always learning new things.